Your goal after watching this video is to be able to identify the parts of a power, to evaluate powers, especially when they include integers. All right, so what you see in front of you right now, the big 2, the little 3, that whole thing all together is called a power. We can break a power down into 2 parts. We have the base. The base tells us what number is being multiplied, what factor is being multiplied. So in this case, 2 to the 3rd power, our base of 2 tells us that we're only multiplying 2's. All right? Our exponent of 3, our exponent always tells us how many times that base is being multiplied, or how many times that base is a factor. So 2 to the 3rd power means 2 times 2 times 2, which also means 8. So let's review a few of the basics. 3 to the 4th power is the same as saying our base of 3 is the number being multiplied, and our exponent of 4 tells us that it's being multiplied 4 times. If I would evaluate that, 3 times 3 is 9, times 3 again is 27, times 3 again is 81. All right, so 3 to the 4th power is the same as 3 times 3 times 3 times 3, which is the same as 81. Let's check the next example. 5 to the 3rd power. I know my picture. It's 15. All right, so I'm guilty of that. I will tell you, in my past life, I am guilty of saying 5 to the 3rd power is 15, or 6 to the 2nd power is 12, or 2 to the 3rd power is 6. But if the creators of this problem wanted you to get an answer of 15, they would write 5 times 3, or 5 times 3. But notice that is not what the problem says. The problem is a power. It says 5 to the 3rd power. So I look at my base. My base tells me that 5's are the only number being multiplied, not 3's, just 5's. Then I look at my exponent, which tells me how many 5's I'm multiplying. I'm multiplying 3 of them, which gives me 125, which is far, far different than if you had said 5 times 3 is 15. 125, if that's the amount of money I have, I'd way rather have that than 15. So 125 is the same as 5 times 5 times 5, is the same as 5 to the 3rd power. Last example, best for last. 6 to the 2nd power. I know my first root is 12! All right. 6 to the 2nd power. If they wanted you to say 12, they'd say 6 times 2. That does not say 6 times 2. We look at our base. It tells us we're multiplying 6's and only 6's, no 2's. Our exponent tells us how many times we're multiplying our factor of 6. So 6 times 6, 36. All right, so 6 to the 2nd power is the same as 6 times 6, which is the same as 36. Okay, now we're going to mix things up and throw in negative integers. When you're working with negative integers, you have to be really, really careful for parentheses or no parentheses. So we're going to start with this first example right here. Exponents are strong, but they're not super strong. They can only apply to the base, the thing directly in front of them. So this 2 that you see, this exponent of 2, only means 2 of the thing directly in front. So in this case, there are 2 3's being multiplied. This negative out here, there are not 2 negatives, there's only 1. All right, so we can view this as negative 3 times positive 3, or we can view it as negative 1 times 3 times 3. Either way, we'll get the same answer. So I'm going to do my 3 times 3, which is 9, times a negative 1, which is negative 9. Oh, $9. Not super happy about that. Now let's look at this example. Exponents apply to the thing directly in front. And if the thing directly in front of an exponent is a group, it applies to everything in the group. So this exponent of 2 is telling me there's 2 of everything in this group. There are 2 3's and there are 2 negatives being multiplied. All right, so in this case, I have negative 3 times negative 3, which gives me positive 9. Completely different than negative 9 up here. Let's move on to our next example. Okay, we have an exponent of 4. Applies to the thing directly in front of it, the number or the group directly in front of it. In this case, there's no group, it's just a number. So we have 4 2's being multiplied. Do we have 4 negatives? No, the exponent can't reach all the way over to that negative. There's only 1 negative. So we could say negative 1 times all of this. All right, so 2 times 2 is 4, times 2 again is 8, times 2 again is 16, and then we have that negative out there. So we get negative 16. If we look at this next example, 4 applies to the thing directly in front of it, and if that thing is a group, it applies to everything in the group. So we have 4 2's being multiplied and 4 negatives. And in this case, negative times a negative, positive 4. Times a negative again, now we have negative 8. Times a negative again, now we have positive 16, which is different than the negative 16 we got in the example above it. Let's move over to our last example. So here we have negative 5 to the third. There are 3 5's being multiplied and only 1 negative. Sorry, that's supposed to be a negative. There we go. So 5 times 5 is 25. Times 5 again is 125, so we have negative 125. Let's look at the example below it. We have 3 5's being multiplied, and there's a group right in front of the exponent, so we also have 3 negatives being multiplied. All right, so in this case, negative 5 times negative 5 is positive 25. 25 times negative 5 is negative 125. In this case, we got the same answer for both because we have an odd exponent, and when we have an odd number of negatives being multiplied, we'll still get a negative answer. All right, evaluate when a equals or is the same as negative 2. So let's skip the first example for now, and let's go to the second example. First thing I always ask you to do when you know what a variable is, so in this case we know a is the same as negative 2, I always ask you to put it in parentheses. And when you trade negative 2 for a in the expression, you should always put it in parentheses as well. So let's start with this one. All right, we have negative 4. A is the same as negative 2 to the third power. You should always evaluate exponents before you multiply or divide. So I'm going to grab my highlighter. Here's my exponent, and whoa, there's a group in front of it, so it goes to everything in the group. Negative 2 to the third power, negative 2 times negative 2 times negative 2 is negative 8. All right, so this part is all taken care of. We know that that's the same as negative 8. Now we just have to take negative 4 times negative 8 and get positive 32. Let's move over to the last example. I have negative, we could view that as negative 1 times the absolute value of negative 4. We know that a is the same as negative 2 to the third power absolute value. All right, so absolute value is like a group. You do this stuff inside it first and try and condense it down as much as you can. So again, exponents before you multiply. 3 applies to everything in the group. So negative 2 times negative 2 times negative 2, again, is negative 8. So now in our absolute value bars, we have negative 4 times negative 8. So I can do that part. I get 32. So now I have, whoops, let's get rid of that. That's from before. We won't worry about that too much. All right, so now I have a negative out here in front. In other words, I have negative 1 times the absolute value of 32. So now I'm going to take my 32 out of absolute value jail. It comes out of the absolute value jail feeling positive. It's out from behind bars feeling positive. And now I still have this negative 1 out here. Negative 1 times 32 is negative 32. Your job and your proof of watching this video is for class tomorrow. Please bring this problem, show your work, show each step you do. Please rewrite the problem where instead of a, you have negative 2 in parentheses. Work it out. I will check that in class tomorrow.